Okay, um, welcome everybody. So this is our third in a series of Mojaloop webinars that are exploring many aspects of Mojaloop. My name is Simeon Rico. I work for the Mojaloop Foundation as the Director of Community. And it's great that you could all find time to join us for this particular webinar. Just a couple of housekeeping. You will see that this webinar is held as a usual meetings. If you have any questions, please put them in the chat, and we will get to the questions at the end of the presentation. This particular webinar is to provide you with insights into the various deployment options that the Mojaloop open source software supports and its various infrastructure targets, aspects rather. We hope to explore the basics of Mojaloop's deployment options, either for development or demo purposes, including a fintech sandbox. You'll hear quite a bit of that from Sam. And then following that, we also would like to have a conversation with David Fry, who will discuss Mojaloop's infrastructure as code and how organizations to reliably and repeatedly Mojaloop schemes. So that said, I want to introduce our team today. We have James Bush, who is the engineering director for the Mojaloop Foundation. And then we have Sam Kumari, who is also the technical director for the Mojaloop Foundation. And lastly, we have David Fry, the director of cloud infrastructure at INFITX. So I will pass it over to you, James.
Thank you, Simeon. Well, first up, actually, we're gonna have Sam talk to us about some of the deployment options for Mojaloop. As Simeon mentioned, not just for development and testing, but also production deployment options. And after Sam has done that, I'm going to probe David's knowledge on our infrastructure as code, which is our equivalent to a software installer, if you like, for deploying Mojaloop into various different environments. So without further ado, over to you to kick us off, Sam.
Thank you, James. Let me quickly share my screen so that we have something to look at. And this is the starting slide, but can you hear me okay, James, and see the screen?
Yes, all good.
Thank you. So if we were in person, or like if we more informal session, I would have asked how many of you have deployed Mojaloop locally. It's actually interesting because there have been several ways to deploy Mojaloop over the years. Obviously, infrastructure as code is something that we used for the very high level environments. But for demo, dev, QA, testing, and pre-prod environments, we had several different tools. Probably some of you have used the Mojaloop testing toolkit. So we had that for a long time. We have something called on-premise deploy, which deploys Mojaloop along with the SDKs and payment managers. And then we had Miniloop. And recently, though, I wanted to today in this session, in the few minutes I have, I want to touch on two modes of deployment. One of them being core test harness. So core test harness has been one thing that has recently come up, and our dev teams are absolutely loving it. And they've been enriching it with many different feature set as well. So initially how it started off was actually the simplicity of it was what attracted many people to use that kind of deployment. So this is a Docker Compose based deployment. We have the bare bones Mojaloop core services. Most of you know the various services that cater for the three-step Mojaloop transfer and the extension. So we have the account lookup, coding, ML API adapter, and then of course central ledger, and several services that are supporting that. And then of course we have the backend dependencies like Kafka, MySQL, in some cases Mongo. So those kind of third-party external dependencies as well. So this deploys those in using Docker Compose. And then we can, using the TTK UI, the testing toolkit UI, which runs alongside as well, we are able to execute P2P and some limited set of tests as well that exercise these various core services. So this has come along a lot, and a lot of people have been adding many things to this. So recently, we have a PR open, which adds the FX functionality to this, along with we also have monitoring options like Prometheus, Grafana that can be used. Along with this, we have finance portal included as well, which shows the transfers that are sent. But all this is for dev and demo purposes. I think that's very clear by now. We don't have the ORI and other stacks that actually help with security, help deploy security. So that is not there. That's why this is mostly for dev demo and QA options in some cases. So here is a repo. What I want to do today is actually take the README page as is and walk through the deployment. Hopefully the demo goes well, like while we are running it. But so that's what I want to do with these two options. So this is the first option. And the second one I want to touch on was Mojaloop Helm install. So Mojaloop Helm install is this is a very critical aspect because this can be deployed as bare bones Mojaloop as well. Bare bones, when I say it doesn't have like the gateway, for example, the gateway or the security stack along with it, but it has all the functional parts of the core services, and it can be used for dev QA purposes. But the key thing here is that these are the same Helm charts, same images that are used even in or higher level environments as well. When you talk about IAC, so the center of it is still these core charts and these images. It's just that we have many different services that support these for key management, for public key infrastructure, and then for gateways and testing tools, integration toolkit, those kind of things that come along with the IAC. But at the heart of it is still a Helm install of Mojaloop or Helm of Mojaloop. So I want to look at that as well. Again, we have this basic deployment guide, technical documentation. I want to see time permitting. I want to actually run alongside some of the key steps there and run it and see and show you how Mojaloop can be deployed using that option as well. So the one other point I want to touch on the Helm install side is you have to set up a Kubernetes cluster. And the deployment is primarily in two steps. Number one is we deploy the backends. So the backend would include the non-Mojaloop components that are required, like the messaging platforms, the databases, streaming platform, those kind of things, like MySQL, Mongo, Kafka. And then the second part would be deploying actual Mojaloop. Once those two are there, deployed, then we can view it using the TTK UI if TTK is deployed, or from Lens. Lens is an app which we use to view these clusters, the pods, and logs and follow along as well. So once that is done, we can even run a test collection on the Helm install. So if there is time, I'll go through that as well. So David and James and even probably others from the community as well, what I'll do here is I'll go through this step by step, and some of these might take a little bit of time. So while that is ongoing, I'd like to talk and have some description. So feel free to ask questions or add anything that you feel is relevant as well. Any questions so far? If not, yeah, let me get started with the core test harness side of things. So let's take this core test harness README page. Yeah, this is the README page, and this is very simple. Most tech members or devs have these already, the prerequisites: Git, Docker, Docker Compose, and then you clone the repo, go to the repository, and then I'll just copy and paste the command. So here I have Docker running, and let me see if I can share my entire desktop quickly. I'm sharing my entire desktop. Can one of you confirm you can see this terminal?
Yes, we see your terminal, Sam.
Thank you, Jim. So I'm in core test harness repository. I just copied this command here and I'll run it. What this does is in our Docker profile, we've created all these profiles, like to run the various services. You'll see that some of these are the dependencies that we talk about: MySQL, Kafka, Object Store, and the rest are actual Mojaloop core services. There are a few, like for example, the simulator and the testing toolkit, which exercise the tests and then give us a view of what's going on in the background and help us to run the tests and invoke those API calls as well. So this shouldn't take too long, but what it brings up all these services. Let me share. And then it even runs the provisioning as well. So let me increase the font size here. Okay, these are coming up, and it runs the provisioning as well. Let me go here. So it brings up all these services, the core services, and then once we see this, this is a basic P2P that it runs, and it gives a result. So if we are following the command line here, we should come to that point very soon. So it brings up all the services, it runs the provisioning, and runs the test as well. It should probably take like 2-3 minutes. We have options to run a P2P again separately. So you can run using a Docker compose command, or you can run from the TTK UI as well. So now that we run it, I'll follow along the instructions here. If you see, here we have the TTK UI running. So I'll go there, and let me see if I can open up a demo page. And in the demo page, we have a demo monitoring, and let's say a mobile simulator. So when everything comes up and running, let's see if we can exercise the transfer here quickly as well. So right now it shows all the requests that are coming in. All these participants' requests are setting up the various test FSPs required so that it can then run the tests once if the provisioning is complete. So let me go back to our README page. And once TTK has now a feature where once a test collection is run, you can access the report for that later as well. And various profiles are available here to bring up various features and various services as well. If you only want an individual service like Central Ledger, that is possible. Account lookup is possible. Or if you want to bring up only the components only required for transfers or agreement or disk or any phase, that is possible as well. And so here is a list of the various profile combinations to bring these up so that you can do development testing and demonstration using those as well. This can be used for functional tests inside CI/CD as well, because it brings the images and runs the same test collection. So that can be used for regression testing. This has also been used for running performance tests in the past. Like in the past 1 year, there's been a lot of performance testing done, and this can be used for that as well. And we have monitoring also added to this. So we have the various monitoring aspects like Grafana and Prometheus are probably the most used, and there are others as well that we can use to view what's going on with the current deployment as well. So I think we are getting close to finishing this up. And yeah, it's been used for load testing, thanks to all the contributors who have enriched this. Initially, it was just a simple Docker Compose, but now we have many features for partners from the community have worked on this in adding various things as well. And I covered a recent feature, and there are many FX feature was added to this as well, and the monitoring options were added. So it's adding more value to this, along with the finance portal. So finance portal is something we wanted to have to show a view that the DFSPs that are onboarded that. So that is a great value addition as well. So please go through this, and if you have any questions, we can discuss on Mojaloop Slack, or you can raise issues here. There is a branch FX implementation. Yeah, and there is a PR open for this as well. So we have a pull request open. And in this branch, we have several extensions as well. For those of you using Macs, some of the images are published, do not support ARM. We now have features that help with that as well. Okay, let me come back to this. You see this now, we have a sum of the test assertions, and now it shows that the provisioning is done, the test has run the basic test, and it has passed. So I'm just following what's there in the README document here. And you can see that we have a running deployment. I'll go to Docker PS to see the services that are running, and you can see run it again. You can see the coding service account lookup, the bare bones code services, and some supporting services to help with testing. Now, going to the TTK UI, we can bring up the collection. You can go to that folder in the repository. So we are in ML core test harness, and there we have several collections. So we can upload those collections, run them. I want to quickly run the P2P here and show how it's running. So it's just run automatically, but you can see that we can also run it using the TTK UI, the 27 here, same as the one that was run automatically. And let's try the demo page quickly. So this is doing the lookup. And then when we select this, it does a code. And it proceeds with the transfer. You can see that the sequence diagram is up. And in the monitoring page, you can see the various requests coming in and going out, like all the get parties, then starting with post codes and then post transfers, and then the final notifications. So this is our core test harness, fantastic tool now, and the teams that are working on streams doing extensive work on this to enrich what we have there, to create more and more, so that it's very easy to have a deployment locally using Docker for development, QA, and demonstration purposes. If you notice an issue, feel free to engage with the community and the devs that are working on it. And also, like if you want to propose a fix or propose an improvement, welcome as well. I'll start for the core test harness.
Thank you,
and then
Sam.
we'll, yeah, go ahead, James. I want to show like how we can do the Helm install as well, but it looks like we have about 50 minutes left. So
yeah,
let
maybe
me check with you.
Yeah, maybe Sam, if you start a Helm install, then we can come back to you at the
Yeah.
end and see how it's gone. I'm sure there'll be some people interested in seeing how that
Yeah,
goes.
let me quickly show that. So I'll show a few things and then I'll pass to you, James, and then you can continue with the session. So I want to show, I have Lens here, and you can see, I'll pick a namespace here. There is nothing here effectively on Moja 3. Yeah, and I'll do a Helm list quickly. And you can see there is no deployment here. Now, if you want to track this with me, you can open this docs.mojaloop.io technical guide and follow along. So in this, obviously, you'll need to have a Kubernetes cluster, and there's some documentation here around how to do that. I want to show those 2 steps I talked about earlier. So there's some prerequisites here, like adding the Helm repo and updating it. But here you can first create the example backend by deploying this, and then the Helm itself. So I'll start the backend deployment, and then we'll pass on to James. So you can copy this command from the README page as well. It's the same essentially. So what we'll do here is Helm install, and I'll install the backend chart. So the command here, namespace mojo3 install backend. This is from this README page, this command, deploy backend. And yeah, let me pause there. I'll show Lens once, and you can see it will start getting populated. Once the command is run, everything will be there.
Okay,
You can come back. Thank you.
Thank you, Sam. Yeah, we'll come back to you at the end and see how that's going. We will share the links to all these documentation pages with all the participants in the webinar as well once we close today. So we've seen from Sam some deployment options for development, testing, and QA into either a laptop or a small number of servers. But next, I'm going to talk with long-term community member David Fry about our infrastructure as code. Before I start, I'm just going to share a couple of slides with you. I can find the right page to show. So, okay, David and I are going to talk about our infrastructure as code, which is our way of deploying production quality, secure Mojaloop switch instances. Our ISC supports deploying into several different scenarios, different infrastructure profiles. We currently support bare metal, virtualized infrastructure, so a hypervisor layer on top of bare metal. Microsoft Hyper-V or VMware is all supported. We also support private cloud, things like OpenStack or Red Hat's OpenStack-based private cloud, as well as public cloud. The ISC is modular and allows you to choose your deployment target. All of the common cloud providers can be targeted with our ISC, and this enables adopters to run their Mojaloop switch instances in combinations of bare metal or public or private cloud or various hybrid scenarios. In our deployments, we use a number of cloud native patterns and abstractions that I imagine many people in the technical space will be familiar with, as Sam's mentioned, Kubernetes, and David's going to talk to us in a lot more detail about the patterns and the technologies underlying our IAC. So, David, you've been in the Mojaloop community since the very beginning of Mojaloop in 2016. Could you maybe explain to us what infrastructure as code is? Tell us a little bit about the history of infrastructure as code patterns, where it all came from and why it evolved to look like it does at the moment.
Sure. So infrastructure as code is something that evolved with the community of sysadmins need to manage virtual machines and networks and do it in a way that that would be automatable and that would essentially eliminate as much human error as possible from the process. So I think anybody who was around at that time, and in terms of how virtual machines were created, and even before virtual machines, physical hardware, there was a sysadmin or a group of sysadmins that were responsible for maintaining the fleet. And there's a phrase, cattle versus pets, that's used in the infrastructure as code space, and that really is referring to how virtual machines or servers and other aspects of infrastructure were treated very carefully. They were pets essentially. You didn't want to lose one of your servers because you had certain configuration that somehow somebody that you forgot was able to get working, and you're not exactly sure which configuration file was the magic fairy dust that they sprinkled on it, and you don't want to touch it. And you get into this position of fear of changing anything because you don't know how it actually got built in the first place in a working state. So pets refers to this, you have named servers, you're careful about them, you know that one doesn't act like the other one, and it's not a reproducible build type situation. Cattle is referring to your assets more as commodities, and you don't care what the name is of it because you're going to destroy it and rebuild it. And you get to the point of being able to reproducibly create your infrastructure in the exact same state time after time. So the worry about losing a server and being able to rebuild it goes away. You embrace the constant change of configuration, running the deployments so many times that it becomes second nature just to destroy something and rebuild it from scratch, because you know you can get back to your desired state just as easily as you did it the first time. So there are tools that were that evolved in that space, and I'd say Ansible was, is probably one of the first very mainstream tools within the space that uses a declarative manner of describing what your end state is. So I want X number of virtual machines. I want them to run Ubuntu 20.04. I want these packages with these versions installed, and I want to have these configurations laid into some directory within Etsy, and I want everything to have system services that are going to be enacted on reboot, and I want all of that described in a YAML file that will say this is, or a series of YAML files, and there's a notion of playbooks within Ansible to describe a whole bunch of configurations that you would like to, that just describes your end state. And you don't care how Ansible really executes that behind the scene. You know that it's going to execute it in an idempotent way, which means that it can be executed n number or more of times with the same result and no negative side effects. So you can always execute it, and if there is no drift of configuration on your infrastructure, then nothing is going to get changed. So the tools like Ansible were really getting pushed into the physical and virtual machine space in order to maintain end state of your infrastructure. And as people realized that this pattern was a good one, they wanted to extend that into other assets that are being deployed. And you can imagine that there's applications that you want to have deployed in a consistent fashion, same versions and same configurations. And so there were tools that started to develop within the space. Terraform is one. Terraform also came into being to support doing cloud deployments. But ultimately, the approach is that anything that exposes a CRUD API is applicable in terms of using tools like this in order to do the initial creation, keeping those resources up to date, and eventually deleting them when you're done with them. So those APIs that could be APIs for SaaS services, they could be APIs for cloud infrastructure services. All of those are appropriate for applying this same pattern of declarative based configuration for your whole infrastructure stack, from the network and the virtual or physical machines up to the applications and any say services like a managed service that you would be using for databases. All of those are candidates for using this declarative approach to establish your final state and have the tools actually execute in order to keep that state current.
So the Mojaloop IAC that you can download from our GitHub repository, that includes the picture, the single source of truth that's the template for deploying a Mojaloop in a production quality secure way. That includes everything from network configuration through virtual machine configuration, firewall configuration, application configuration, the whole stack. Am I understanding that right?
Right, and I think that you could do a deployment using the Mojaloop IAC repo as the source of truth for all of those components, or if you don't want to use all those components, then you could use a subset of those. Like in some cases, the whole stack wouldn't be appropriate, especially if you're on bare metal and you're bringing up your servers and you're bringing up your network and your firewall, et cetera, in a manual fashion. or maybe you have a different way to automate the deployment of those assets, then those parts wouldn't be appropriate for including, and you wouldn't include those, but you would include the other portions of the stack. So it's a modular approach to both the infrastructure as well as the application stack that goes on top of it.
Understood. Thank you. And I've heard lots of talk about the GitOps pattern. Could you tell us a bit about the GitOps pattern and why we use it in Mojaloop IAC, what it is, and why we use it?
Sure. So I mentioned Ansible and I mentioned Terraform. So these are tools that take an end goal, an end state, and then achieve it. And how they achieve it is kind of a black box in some sense, that you don't really care how it achieves it. And the pattern that for deployment of these tools, be it Ansible or Terraform, has been in the past. Usually you would have a CI server that would be running, and you would point this CI server to your infrastructure that you would want to deploy. And obviously those are not usually on the same network. They're not usually necessarily in the same data center. You would have potentially different data centers that you're deploying to, and you would have a build server that is running in its own network. And you could imagine different scenarios of how you would run that. However, in the past, given that model, the build server, so to speak, that runs Ansible and runs Terraform would need privileged access into the environments that it's deploying to. And so that brings up an issue, which is that you need to put configure a hole in your firewall for a particular build server, and you start opening up vulnerabilities, and possibly if you're using that push model. So the GitOps approach is, instead of having a build server that's monitoring an external deployment and then comparing it to a desired state, the desired state is stored usually in a Git repository, and now the GitOps server is running within the cluster, within the target cluster that you're deploying to. And that GitOps server is pulling its source of truth, either internally or externally in a Git repo. And then it applies that configuration to itself. It monitors itself for drift, and then applies any needed changes to itself. So this turns it into a pull model. It pulls the source of truth and applies it to itself, and this eliminates the security risk around using a build server and needing access to sensitive services within the deployment.
So we're not just talking about infrastructure components here, we're talking about software as well. So instead of pushing new versions of software into your infrastructure, let's say there's a new version of Mojaloop or a Mojaloop service that's released, and you stop pushing that software in. You let the infrastructure notice that there's a change, and it goes and securely pulls that software in. So you don't open any doors for potential attack.
Correct. And you also use version control and tagging in terms of using release tags on this infrastructure as code to control when changes can be introduced. In other words, you don't use the anti-pattern of pointing to the latest tag or the main branch in a Git repo. You only used tag releases so that you have control for when things get deployed, because this is an important concept to always keep in mind when you're using GitOps. So there's some cases where maybe you always want to be on the bleeding edge, that tends to be on your development servers. But as you go up the stack in going towards a production release, you want to make sure everything that you deploy is a tagged version. And GitOps definitely is honoring that kind of design pattern to only be working on given tags as opposed to branches.
Yeah, thanks. I can see how that gives you, from an operations perspective, a really clear picture of change history to your infrastructure and your software deployment.
You can use the notion of pull requests or merge requests in order to enforce a change control in that sense, right? So you can use these time-honored approaches within Git in order to make a pull request and only have an approver be able to actually merge those changes into the main branch that you're using to for GitOps to pull the source of truth. So those work very well. Those concepts.
Understood. So it's a much stronger mechanism of controlling changes in your infrastructure.
Exactly.
Than traditional approaches. Okay, I understand. So the next thing I want to ask you about, David, is how these concepts apply in the Mojaloop world. So I have one more slide I want to show that I think will, I hope will illustrate my question. Just need to find the right slide to share. Here we go. There we go. So my understanding is that the IAC and the GitOps patterns that we have in the off-the-shelf Mojaloop IAC repositories implements this pattern of having a control center which holds the source of truth for one or more Mojaloop switch environments that then get deployed, and following the GitOps pattern, they pull their changes from the control center. Could you maybe explain to us in a little more detail about how the control center pattern manages the switch environments and how everything gets synced up?
Sure. So the control center is just a name for a bunch of capabilities that we're providing for the various environments that we're spinning up. And so some of those relate to GitOps in the sense that we, in Control Center, we provide a Git server, namely GitLab. And each of those environments that get spun up will have a repo within that GitLab server that represents the source of truth for that environment. So let's say in your previous slide, you showed 3 environments. Well, there'll be 3 repos one repo for each of those environments. And there'll be a repo for the control center as well. And so not only does the control center provide the capabilities for the environments, but it also provides that capability for itself. So each of those environments is running Argo CD, which is the GitOps implementation that we use. And that Argo CD for a particular environment is pointing to the repository within Control Center to get its source of truth. And so the Control Center outside of GitLab, it's providing other services as well, secrets management, some objects storage. So in this slide, you can see that we have object storage, and we use Vault for secrets management. We have Nexus that's providing a private image and Helm chart repository. And we have Argo CD, which is providing the GitOps capabilities for the control center itself to keep itself up to date. And then up on the top, we have NetBird, WireGuard Mesh, and we have Citadel, which is the identity management platform that ties together all the OIDC application configuration for the environments and for itself. And then around the periphery of this box, you can see that there's various APIs that we're interacting with, cloud provider DNS API in that situation, an RDS AWS database, an EKS Kubernetes cluster that's running Mojaloop, and then we have a Kubernetes cluster running on top of some VMs and AWS running micro K8s in that instance. But all of them are using the shared services of the control center in order to get their source of truth, as well as to make use of these shared services, like the WireGuard mesh is allowing secure access to certain services, both from the Kubernetes clusters of the Mojaloop environments, but also to manage databases like the RDS instance in the bottom left. But
so what we've got here is all the components that you would want and need to have a best practice, extensible, maintainable, secure business that operates Mojaloop switch environments. You're strongly controlling who can make changes to your switch environments, who can do what to what. You're securing all your secrets, your passwords, your crypto keys, etc. And that's all very tightly managed by this control center pattern, right?
Yeah, and one thing that's missing from this and needs to be added is the monitoring stack. So we do have the Grafana stack that's deployed both in the Mojaloop clusters as well as within the control center. And the one in the control center actually is using Mimir from Grafana, which actually allows you to pull data from your various environments into an aggregated view within the control center. So control center is really designed for operations teams that need to manage a fleet of Mojaloop deployments, and it allows access control into those environments, as well as monitoring of those environments at an environment level, as well as at an aggregate level in the control center.
Okay, the next thing I wanted to ask you about was the different types of environment we've got here. On the slide, you can see we've got one labeled as a development environment, one as a pre-production, one as a production. I can imagine there would be different requirements for each type of environment. A development environment wouldn't need the same level of reliability or redundancy or performance as a production or a test environment, maybe. Can you talk a bit about how IAC enables you to optimize the efficiency of the environments that you're managing with Control Center?
Sure. So the approach that has been taken with the different environment types is a profile concept. So the profile is designed to group certain configuration information or certain configurations, I should say, from the infrastructure side up to the application side in a common profile, and that allows instead of you having to remember to tweak every button in a certain way for a dev environment, it allows you to group those changes together in a named profile, and then those named profiles can be shared in a Git repository. Or you could create your own private repository, and you can make use of those as you see fit. So as you use Mojaloop and you can start off with certain profiles that already exist in the open source space, and then as you run your own Mojaloop and you see what your own demands are for certain services, you may want to tweak those and create your own for your own private deployments. So that's the concept of being able to use named profiles for different deployment types. And those include, as you mentioned, right, dev, you're going to have less requirements. In terms of responding to load, there's going to be horizontal scaling that you're going to want to configure appropriately for different services. And again, those are all going to need to be tweaked as time goes on, and you and you discover your own sweet spot in terms of those configurations.
Understood. Thank you, David. So also, I believe those environments they can target. I think we may have even mentioned this at the start. They can target different environments, cloud, on-prem, but you also have the ability to change those profiles over time, right? So if you were to build a development environment to start with, and you realized you were hitting the limits of the hardware, you could tweak that and increase the capability of that environment. And I think the same is true of the test and production environments, and having the ability to spread those environments across private infra, be it bare metal or virtualized and cloud, and change and tweak those levels of provisioned hardware. That's something that's provided off the shelf, right?
Definitely. So the configuration is designed so that you have default configuration settings that can be overwritten in a customization folder, and you only have to override the things that you want to change. But some of those changes might be the size of the virtual machine or the storage size and number of replicas. So there are a lot of configuration options. Most of the time, you don't want to have to touch them, and so you can just touch the ones that you want, and that is can be done on a per profile basis. So you could say that the size of the VMs in a dev profile would be much smaller than they would in your staging, or maybe they're the same, but you're using a different number of worker nodes in staging versus dev, or the list can go on and on and on. But that's how the underlying infrastructure can be configured based on a profile, and then the profile can be configured based on which environment that you're deploying to.
Yeah, understood. Thanks. And I think we have some rough numbers around some of the sizes of the profiles, the number of CPU cores, and volumes of RAM that have been produced by the community during our performance testing for reference. I think we'll be sharing these slide decks with everybody after the event today. So thank you very much, David. Just one final question. We have all this amazing capability off the shelf in our open source GitHub repositories, and we have a volume of documentation as well. What would be the best place for people to go to next? If I know I'm new to the Mojaloop community, I know I need to deploy a Mojaloop. I've listened to your talk today. I want to start using IEC. I want to experiment with it. Where should I go next?
Well, I think that in terms of preparing yourself to deploy Mojaloop, I'd say there's two large concepts that need to be digested, and one would be Kubernetes, right? Because Mojaloop is a Kubernetes-based application, so you need to get up to speed on containerization, number one, which I think a lot of people are using Docker. However, from an orchestration, a container orchestration engine perspective, Kubernetes is what is needed in order to be successful in deploying Mojaloop. And you saw that with Sam's presentation earlier, his demo. So there's various ways to get Kubernetes running and get Mojaloop running, but I think you really need to get familiar with the basics of Kubernetes, how it works, how you troubleshoot it, how you secure it, how you provide access from outside a cluster, and all of those elements that you don't get just by doing a tutorial, right? So, and the second thing is that Mojaloop is an open source project, which I think we're all aware of, but so is Kubernetes. And And I would mention now that everything that you saw in the diagram that you showed earlier and everything we've talked about, all of the components are open source. There is nothing that we've put in the infrastructure as code that is not open source. So that is a good thing, and definitely in terms of operating budget, but it also means that you have to be familiar with how to use open source software projects. And that means knowing how to navigate GitHub issues, how to maybe start becoming contributors in different key projects, especially those that where you might need some changes done. So that's a whole new ball game for those that are coming from a more commercial off-the-shelf application usage background. So
if I have sorry, David, if I have an existing IT team who maybe manage more traditional applications, a lot of the skills will be transferable there, right?
I most definitely, especially Linux skills are going to be transferable. I would imagine that within the IEC tool chain that Ansible is probably something that exists within the as a skill with the existing teams. Terraform, maybe not, but definitely that's something that is easily acquired in terms of a skill. And the GitOps approach, Argo CD is the tool that we use. Flux is another tool, but those are things that they should start looking at for experience in their staff, and start looking at self-paced training for all of them to get them up to speed in those. And obviously Kubernetes, lots of training available online, and that's going to require definitely study, and more than study, actual usage is where you're going to get the best experience.
Yeah, understood. Thanks, David. I do know there's certainly an awful lot of free online training material for all of these tools. So managed services, one important thing about our ISC that I'm aware of is that the defaults by off the shelf deploy in cluster resources like database and Kafka, but many adopters in the past have balanced the provision of managing their own backing services like database and messaging plane with paying maybe a cloud provider to manage things like that for backups and redundancy and reliability. All of that is taken care of with IAC, I understand.
Right. So the way that the IAC was designed for Mojaloop was to be able to swap out databases in particular for either in-cluster deployment or managed services. So there's a bit of indirection that's happening in terms of how we point the Mojaloop applications and other applications to the data sources that they use. And so those data sources can be swapped out by changing configuration. So you can create a managed database service, and then you can create the credentials and configure the Mojaloop cluster to point to that managed service. Or the default is that for the MySQL databases, that Percona database will be created within the cluster, and the service, the application will point to the internal in-cluster database. But again, that's the same thing with Kafka. We use the Strimzi operator for Kafka, and that is the default. But it's also possible to use the managed AWS's managed service. I think it's MSK. And so these are designed to be essentially configuration driven as opposed to changing code.
Understood, David. Thank you. So that's an important business decision for adopters, the balance of managed services versus having your own team of DBAs, maybe who know and understand the database technology and can manage your backups and things like that. Okay,
Exactly.
so I noticed that we're running short of time. We will share after the event. We will share links to the GitHub repos for IAC and the various slide decks that we've talked about. So just before we go to Q&A and open the floor to questions from anybody, if you have questions, please pop them in the Zoom chat now. While you're doing that, I'll just hand back to Sam, who can give us an update on his Helm install. How's that going, Sam?
No, it went great, James. I want to say two things. Is just with those two commands, once we have a successful Kubernetes cluster, we have a Helm deployment with Mojaloop, which can be used for development QA. In fact, we use such a deployment for our QA purposes, where we run a cron job daily. So it was very straightforward, just those two steps. In fact, we deployed that with one of our recent demos as well, that the merchant payment workstream did. They had an on-prem cluster with Kubernetes, obviously, and just those two commands, even with the default values passed, and it runs, instead of running a 27 assertions like how we saw in the core test harness, it runs the whole GP test. Like there are about 2,600 tests, and all those just passed even with the default values. So
fantastic.
Yeah, all good. And yeah, great to hear this as well. In fact, I was wondering, I don't know if you had this question in mind, but I was wondering how David and our maintainers stay on top of the tooling and keep changing tools. Like there are so many of them, like Argo CD, Citadel that you introduced newly, and the gateway. So how do you keep track of what's going on? James, but yeah, I'll pass on to you that update.
Yeah, thanks, Sam. Thank you, Sam. So I don't see any questions in the Zoom chat. David, should we address Sam's question? How do we stay on top of all the many changes that come frequently in the open source tooling world under IAC? We have a pretty busy maintenance schedule.
Yeah, there's two things. One is that obviously the open source tooling is not 100% bug free, right? There is constant issues that are being created on the GitHub repos for the various projects that we use. And we have issues that we create within the IAC repos to track the workarounds that we're doing for an upstream issue. And in some cases, we fork the repositories that are in use and make internal changes, and then we have our own release that we do. So it's not it's not a panacea, right? Using open source has its own challenges, but you know what? Whenever you're faced with an issue, if you have to, you can always crack open the code and look at it, and then you go, oh, okay, now I see why. And then you can make a PR against the project, and we've actually worked very closely with some of the projects like NetBird. We've created a Terraform provider for NetBird within the Mojaloop space. We've also contributed to the NetBird Helm chart. So we're contributors in a lot of these projects, and in other ones where we create issues and we track them until they're finished, and then we'll use the correct version going forward and back out our workarounds. So it is a lot of work, but what we're deploying as releasable candidates has been tested, and it works with certain caveats. And then we just keep track of them and make sure that we're using the latest versions whenever possible.
Yeah, understood. So the IAC as a Mojaloop product is deployed and managed and released following the same processes that the other Mojaloop software follows. So we have maintenance periods. We run an agile process, and periodically we make a new release, and the release has a release note with test coverage, etc. So so adopters can have the confidence that when they come and pull the last released version off the shelf, they're going to know what they're getting. They're going to know what known issues might exist within there, etc.
Exactly. And I would also take this moment to say that, our focus up till now has been bare metal and AWS running micro K8s and running on EKS as a managed Kubernetes provider. The other capabilities to work on different cloud providers and other managed services outside of the AWS, ecosystem, those require contributions, and I would love to see community members come and say, hey, I want to see this working on Azure, and we would welcome that with open arms to get more coverage across different cloud providers.
Yeah, thanks. I know there have been attempts in the past to run Mojaloop on different cloud platforms, but those don't use the full IAC stack, so you don't get the GitOps pattern, you don't get all the default best practice around security and secret management, monitoring. Yeah, so although there have been successful Mojaloop deployments in those other areas, they don't follow that best practice that's embedded and wrapped up in the IAC.
Well, one thing that we didn't mention about infrastructure as code is what's embodied there. One of the main principles is dry, right? So don't repeat yourself. And if we have somebody that's doing an Azure deployment that is redoing a bunch of work that's already been done, then either we're repeating ourselves or the other contributor is repeating themselves. So we really like to make sure that we find the best practice way to do one logical deployment and bring it all into the fold so everybody can take advantage of it.
Yeah, fantastic. Well, thank you very much, David. It's been a pleasure talking to you today. So I don't see any technical questions on the content in the chat. I see one question about where you can get the recording. That will be shared on Mojaloop Slack. We'll share a link to the recording on Mojaloop Slack, on Community Central, Mojaloop Community Central. And yeah, Simeon's just posted there in the Zoom chat. It's going to be on YouTube pretty soon as well. There might be a day or so post-production to remove our mistakes and make us look pretty before it goes on YouTube, but it'll be there very soon. Thank you very much, everybody. I shall just quickly hand back to Simeon to close us down.
Yeah, David, James, Sam, thank you so much for providing all those very meaningful insights. Again, the call has been recorded, and this will be up on our YouTube channel. That is youtube.com/@Mojaloop Foundation. Of course, it will take a day or two as we do a bit of post-production, but as soon as it's up, we will also circulate it to all the participants of the call. So again, thank you so much for joining. This has been the third in a series of webinars that help adopters and decision makers understand some of the key nuances around Mojaloop and adopting Mojaloop. Hopefully this has been useful. I do want to also turn your attention to some of the training materials we have on learn.mojaloop.io. There's a slew of courses in there that goes into much more depth about the various topics that we have discussed, including this topic of deployments and infrastructure options. So please do check that out. That is learn.mojaloop.io. Again, thank you all very much. We will see you all again soon. Thanks all.